Okay, we're going to traverse a binary search tree, and we're going to practice both in Racket and Java. So the thing we're going to practice on is node count. And you've maybe seen node count in Racket before. That's okay. You probably don't have it memorized, so trying to practice on it again is going to be helpful. So node count's just trying to traverse the whole tree to see the total number of nodes. Here are some examples, sort of conceptual examples for us. So I want you to pause it, and you're going to write node count in Racket. And you're welcome to reference height for this. And I want you to write node count in Java, and actually you're going to call the method size here. So you can pause it here, or the next thing I'll show you is the hints which show how we did height in Racket and Java. So you can pause it here if you want to see the hint for height using Racket. Next up is Java, and you can pause it here if you want to see the hints for using Java to calculate the height. And you can see the comments show the Racket code too. Okay, I'll assume you've paused it, and I'll keep going. Okay, first step is Racket, and I'm going to write node count. Okay, so I want to do the node count starting at a particular tree, and if that tree is empty, then there must not be any nodes there, so I'll return 0. And otherwise, I want to count the nodes in the left tree of the tree, and I want to count the nodes in the right tree of the tree. And ultimately, I want to add those together, and then I'm also going to add 1 to that count, because I need to count my current node. Okay, there we go. And again, this was super similar to length that we saw in Racket. So with length, we kept adding 1 to the recursive call on the rest. And here in node count, we keep adding 1 to the recursive call on both the left tree and the right tree. Okay, here I've got my size method, and I'm going to do a similar thing of having a helper method. That helper method is going to allow me to traverse with nodes. So I'll make it private, and I'll call it size from node, and it's going to take in one of those BST nodes, and I'll call that node. Okay, so my empty case, the way empty will look here is if that node is equal to null, and in that case, I want to return 0, just like I did in Racket. And otherwise, I can return 1 plus, and now I need the size from both my left subtree and the size from my right subtree. Okay, so that part looks super similar to the Racket. And to make that work with this public method, what we need to do is we need to return the result of calling that method. So we've got size from node, and we're going to pass it this.myRoot. And oops, the variable name is root node. There we go. And I want to draw your attention to the fact that actually all these calls that we were making were on this. And we wouldn't say this.node. That's not legitimate because node is actually just a local variable in our recursive call. But that method size from node is actually getting called on a binary search tree object. But the thing we really care about is traversing by the node, and that's why we were passing it in as an argument. And again, here we can see the Racket version and the real meat, that helper method, of the body of that size method in Java.